All right, now that you have spent some time going around using the camera on some semi-automatic settings just to help you take photographs, to help you get the assignment done, and just to get you moving, feeling the camera, actually taking pictures, we're going to talk a little bit about the settings on the camera that you haven't really had to worry about too much starting or so far. So it's very simple. Cameras are actually very simple. And now we have these digital cameras that have a crazy amount of buttons that do so many different things. And but really, for the most part, cameras freeze time. That's very simple. Well, it's simple in concept, but time, that's a whole other question. It freezes the still image, the moment, its shutter speed, and its aperture, and then there's the sensitivity of the medium, the sensor in this case, that records the actual image. So I'm just going to do a walkthrough on the camera functions, and I'm going to start to talk about what they do, okay? And this is kind of a crash course in these functions, and I will elaborate a little bit more as we go along. So, camera functions. All right. Aperture. What is aperture? Which part is aperture? So, we all have a lens on our camera, and the lens has this diaphragm within it that opens up and closes. When it is open, it lets in more light than when it is stopped down and closed. So the aperture will control how much light enters into the camera. Okay? So, amount of light let in by the lens. So we refer to them as stops, f-stops. You might hear f2.8 all the way up to f64. Our lenses don't go up that high. When you get into larger cameras, the f-stops end up going bigger. And that's a whole different conversation. But for the most part, you are all going to be working probably somewhere between f3.5, depending on your lens, and f22, maybe 32. Maybe you have a lens that opens up even more to f2.8. And what I want to talk about is the number system here. These are, what I'm showing you right now is whole stops. Okay? So that is simple as twice as much light or, half as much light. They're 8 to 11 to 16 is consistent whole stops, right? Here's where it gets kind of confusing. The smaller number is the larger aperture. The bigger number is the smaller aperture, all right? So the smaller the number, the more light's being let in because it's a larger aperture. The larger the number, the smaller the aperture, so the less amount of light, okay? There are thirds stops on most of our cameras. So you'll start to see like these numbers between 5.6 and 8 and 11. And that's just when you start to learn how your light meter works in your camera, and you can make these very slight adjustments with your aperture that aren't in whole stops. This is an example. Between 5.6 and f8, you'll find 6.3 and 7.1. Okay. So aperture is the amount of light that is let in, right? Okay. Shutter speed is how long that amount of light is being let in through the lens, okay? So the lens is not letting light in, and we have our aperture that will let in a certain amount of light, and when we click the shutter button, whatever our shutter speed is set to will determine how long the picture is being made and for how long light is being let in. Same thing, okay? So we will look at our camera's shutter and we can move it around and we'll start to see it goes from, this is a very small section, what I'm showing you right now of different shutter speed times. But what I'm showing you right now is, again, just like an aperture, they work in whole stops. So it's much easier in time because these numbers, the aperture is a little more tricky to actually figure out what those numbers mean. But if we're looking here, a 60th of a second is twice as fast as a 30th of a second. That's just math. That makes sense, right? They made it easy for us so that we don't actually have to do too much math. It's a lot easier once we get from 1/15th of a second. When we cut 1/15th of a second in half, all of a sudden we would have a decimal and they're just like, screw it, let's just call it 1/8. So that's why you see when it gets down, it'll get to 1/8, and then it'll be 1/4, and then it'll be a half, and then it'll be 1 second, okay? So shutter speed is how long the aperture is actually open for. It's how long the light's being let in, and it's pretty straightforward. So we have really fast shutter speeds, like 1/6000th of a second, where it's just the blink of an eye, and that's how you would end up taking a photograph of a hummingbird if you don't just want to steal it off of Getty Images. Thank you, Cal Holman, for your photograph. This is an example of a very fast shutter speed. It's also an example of a very shallow depth of field. This is an example of a very long shutter speed. This was probably it could have been minutes. The light on the freeways of the cars is there. You can't tell that there are cars anywhere. There's no actual image of a car. You just see the trace of light that moved all the way through this city. It was probably a couple of minutes. So the difference between a very fast fraction of a second and a very long image, the difference, you just need a tripod for this photograph, and you just need to know how to use a really long lens. You need a tripod for fast as well. But if you want to have this still cityscape with the lights moving, you have to use a tripod. Maybe someday we won't need a tripod anymore, and we'll be able to use other technology, but that's how this image was made. This is moving with the person. There's somebody moving in the opposite direction. This just shows that if you're following, the world is moving behind what you're following, and then you can freeze that image of the subject that you're following and let the rest of the world move around you. Get on a merry-go-round with somebody, spin, take their photograph. They're sitting still and the world's moving around them. You have to have a kind of slow shutter speed for this. So ISO, we've talked a bit about ISO, and ISO is the sensitivity of your sensor. It's when you're in daylight and you want to use 100, because there's so much light coming from the sun that your sensor doesn't need to work that hard when there's a ton of light. When there is not very much light, then you need to have your sensor compensate, and you have to crank it up. So again, just sort of as an example, 100, great when you're in the bright sun or if you have a powerful flash. 200 and 400 if the circumstances are that it's maybe in the shade. There's also the circumstance that you're photographing a hummingbird, and your shutter speed has to be like really fast. And when your shutter speed is really fast, it means that you're letting light in for a very short period of time. And if there's not enough light, like the bright sun coming down, you might need to bring your ISO up a little bit. It's sort of a give and take all across the board. We're always sort of prioritizing one thing over the other, right? To make sure that we either get the image so that it's still and sharp, that kid's running around, a hummingbird, sports, cars going super fast, somebody's throwing something, action. you're just going to want to prioritize having a faster shutter speed and then adjusting your aperture and your ISO to get the right exposure. If you want your image to be completely isolated from the background, which is a very shallow depth of field, like this image, this is not only prioritizing your shutter speed to accommodate how fast a hummingbird's wings are flapping, but it's also a super wide aperture to create a shallow depth of field. And we'll talk about shallow depth of field and depth of field more as we get into this.